So, good morning. Thank you for joining me early, 8:15 now, tomorrow 8:30. So the reason why we're doing this today is that at 9 o'clock I have some seemingly unpredictable meeting I need to participate. I know it since yesterday, so sorry for that. I'd prefer to have a proper session, especially in the beginning. However, we have a rather short one today, but it's mostly about Linux. Well, I wouldn't say anyway, it's mostly about Linux, right? So how many of you have experience with Linux, one way or the other? Good? Good. How many of you are BitSec, DigSec, that area, information security or operations? Yes? Okay, so it's a good subset already that have some exposure. But what I want to provide today is pretty much an introduction because some of you don't have an exposure, and that's no surprise because we don't teach it yet. The future cohort will have it in the first year, but we don't teach Linux in the first year in Bachelor of Programming, but you guys need to know this operating system, and today I want to motivate as to why you need to know that. One of the reasons, of course, that you may not really have understood what kind of instructions you typed into your computer last week, which is something, it's a classic, classic social engineering attack, Please run this command for me and see what's happening. So we want to be careful with this one, but I think at the end of today you want to at least understand what you actually added, what you actually typed into your machine when you installed Go or the like. How many of you have the environment set up, like Go and so on? Some of you, that's good. I tentatively ask him, but I just want to check carefully. In case, Jone may actually stick around, help you guys that have still some trouble, other than not typically doing it yet, help it debug a bit or set it up. Otherwise, we deal with this tomorrow. Tomorrow we have a full session again. I continue where I leave off today, basically. So you're not missing out. It's just a bit of a shift. I mentioned before the Vorlesung, Öffning differentiation. We don't really care about this. It depends how our lectures fall and how things work out, and then we work around it. So that's the thing. Okay, Linux. Linux. Good. Yeah, who's that guy? Yeah.
Linux creator.
Yeah, what's his name? Okay, doesn't matter. Good.
Torvalds.
Yes, really. From where is he?
Finns. Suomi, Finn.
Yeah. Okay, and more. Does everyone know that? The detail? Which?
You asked me.
Yeah. No. More general. Which country is that in English? For
Suomi, Finland. That's the country.
Finland. So there you go. I didn't hear the Finland bit.
Okay,
Yeah.
it's Suomi.
Yes, I know, but the internationals may not. So, okay. Yes, Finland. So, what did he do? Well, he developed Linux. When did he do it?
85.
Yeah, a bit later. Yeah. Anyone?
95.
A bit earlier?
91.
There you go. 91, right? 1991. So he was at the University of Helsinki, I believe, right? Yes, good. And he was actually looking for an alternative. He was in a similar situation than you. He was actually studying computer science and needed an operating system to run his stuff on. And the options available were rather simple and most likely boiled down to, well, not having access to the real stuff, but need to compromise and work, for example, with Windows or whatever else, which is wasn't an option really for someone who wants to go deep in computers, especially at that time. Nowadays, Windows is kind of a valid option where they use operating system for various use cases, but not at that time to limited access to hardware and things like that. So he wanted to have something that was more Unix-like, because that was the operating system of the time, being the fact that there were so-called mainframes around. We'll talk about this in another talk. But the idea is that central big computers and people could book time on those and actually run meaningful software. And he wanted to have one of those as well on his home machine, right? Well, good luck. Problem is, what was the problem? The software was there. What is the problem with Unix? Why didn't he run Unix on his home machine?
Because it's licensed somewhere, but you
Correct.
have to pay something to use it.
Yeah, that's correct, right? So they were usually made for, it was expensive. You need to buy a license, and there was not the concept, I don't think there was a concept of academic license per se at that time. This was one of the problems. Secondly, they had incredible hardware requirements. So it was not really feasible to run it on his 386 Intel 386 machine. So it was not available there. So he developed it himself and hosted it at the University of Helsinki. It took some time to take off, but he ran it. He actually originally just created it for his home computer, the Intel 386. At that time, everyone thought that would be a personal computer for a lifetime. Of course, it wouldn't be. But Linus Torvalds is also known for, after being successful and actually having shared this system with the world more or less, and now being the most successful open source product, if you want, he's also known for being quite out there and quite explicit about his behavior. Things like that happened quite a bit in his career. Does anyone know when he did this? Or what's the message behind this? I'm not sure if I'm supposed to show it in class, but it's just, popular culture, I guess. Anyone? Please.
He has this lack of social skills. He has an IQ high and an SQ very low, so kind of easy to temper.
That's right. He's very well known for his bad mannerisms. That's right. Yes. So a very good point. So he's not, or wasn't at least. He pledged change, improvement. Wasn't the kindest to his, contributors to the Linux kernel, to the software. But this was specifically targeted at NVIDIA. Anyone knows why? The gamers amongst you, perhaps? Why NVIDIA? Well, they're notoriously known for keeping their drivers for their graphics card proprietary. So Linux was always notoriously behind in terms of performance, behind Windows, in game performance or whatever else when it came to graphics cards. And since NVIDIA didn't want to open up their drivers, making open source, that's the thing here, that's the message to NVIDIA he sent. So he's very explicit about it. He's a strong proponent of open source software. We get to that in a second. By the way, just for the sake of comprehensiveness here, his first post about Linux, which he posted on a mailing list, or a news group rather, this time on the operating system Minix user group. There was a kind of from a Free University of Amsterdam, there was a free operating system available, but it wasn't powerful enough for its purposes. So he said, well, I created something for myself, and it kind of works on my machine. Perhaps it will never make it, but if you have questions or whatever else, please, contact me and so on. So that was the opening to the world in 91. Yes. Okay. But going back a bit in time, I think it's important to understand this, because whatever we learn and talk about in the context of Linux also applies to other. Well, it's kind of a generalizable skill. If you know Linux, you kind of will be comfortable in Unix systems as well. And we want to go a bit into that history. So the first Unix, still written with a CS, was developed in 1969 by Ken Thompson, I believe, and shoot me, I think that was the name of the developer, and in 1969, and it was made for mainframes, meaning large machines with considerable hardware support. You would run one instance of those in a company if you're lucky, or borrow the time to run software from another company, and people would book in and check in via remote terminals. So at that time, people didn't have really local computers like we do nowadays. Oh, thank you very much. But actually, use terminals pretty much looking like this, where you basically log in, but you're actually logging in on a different machine. So it was all network-centric. It was not the time of the personal computer. Over time, of course, there were progressions in versions with respect to support, software availability, and so on. And then after the 7th edition, there was a bit of a split. And Unix split both into some sort of academic branch and in a commercial branch, where actually AT&T took it to the commercial perspective and actually, refined Unix, made it more uniform, gave better support, but also specialized it on high-performance hardware. And then, as a result of this, there's a lot of forks of the original System 5 system from 1983 on the commercial side. And you may have heard in the news, or it may still come up, SCO Linux, for example, HP Linux still around there, or Solaris from Sun, which is nowadays, I don't think, maintained anymore. But those were commercial forms of Unix. If I said Linux just before, it's Unix. So on the other side, there was the BSD, Berkeley System Distribution branch. You may come across this as well. Anyone know a product that's BSD-like? But sorry, yeah? Yeah, it's correct. OpenBSD, yeah, it's not even, yeah, it's not even in there. That's right, OpenBSD, FreeBSD, or any of those. If you come across those are basically Unix forks as well to the BSD side. So Berkeley Systems Distribution, as the name says, it was developed at the University of California, and it was largely held open source. So that was for the academic branch. Still, it had the same kind of problem that the commercial branch had as well. It was dedicated to run on high-performing, mainframe machine out of reach for Linus Torvalds or anyone else at that time. And what Linux kind of did was kind of reunite the best of both worlds again, but not so much by taking the software, but by redeveloping it from scratch. So think about if you have an operating system and you're interacting with this via command line or some other means of interaction. The only thing that you actually care about is this user interface is roughly the same as it should be with a system you know already, right? If it looks like Windows, if it behaves like Windows, most likely Windows. But it could well be another operating system sitting underneath it. And that's roughly what happened here, that Linux actually is this complete re-implementation that is compatible to the hardware available at the time, but fundamentally feels as if you're working on the big ones. So that was the motivation why you came out with this. Okay, so now we kind of know the history, but it's a re-implementation, but it uses the user input interfaces from previous Unities that were out there. So what I'm saying is, if you come to with Linux, you're most likely halfway there managing one of those systems as well. I mean, there's changes, of course. For example, the file system layout has changed a bit. It's not as uniform in Linux as it is in the classical, especially in the commercial branch of Unities. And the software situation is slightly different. So, okay. Is there anything else I want to say? Well, the rest doesn't really matter too much. That should come back in a second. There you go. So, one of the paralleling developments there that you probably heard about before was GNU, right? The GNU collections, GNU software that's commonly associated with open source, right? So, in 1984, Richard Stallman started promoting. Of course, he was, had a group of people being like-minded, but was pretty much going heads-on with the idea of retaining intellectual property on software, specifically running proprietary software. So he was really fond of having a system where you'd be able to actually run only open source software. Right? So, and this was called the GNU Foundation, and they came up with the GNU General Public License. Important for you guys, you're software developers, GPL. Who has heard of the GPL before? Please. Okay, thank you, Juan. I feel a bit better. Okay, we need to have a session on licensing as well as in some stage. Is there a course on licensing that we have? Software licensing? We probably need to talk about this, but not now. So, okay, so there is a public license. The idea there is, well, if you develop a piece of software, you release it under GPL, as you can do, for example, on GitHub, you can actually pick the license. They have a nice set of licenses you can choose. And if you choose the GPL, it guarantees you, well, no one talks about enforcement, but it guarantees you at least that your software will not be used in commercial settings, and everyone has the right to use it, but also if they're modified, need to republish it. Right? There's an obligation attached to it as well. So it's the strongest open source license that we know right now. The issue is, of course, enforcement. If you take someone else's GPL licensed software and you do something at home with it and never share with the world, no one finds out, okay. But you simply can't use it publicly, right? So it's one of the key concerns. There are also, of course, enforcers, some pro bono companies, law enforcement or lawyers and so on, that actually go after violations. But in any case, that's one of the most important outcomes of the GNU initiative. And it was directly opposing the Unix perspective in a sense at that time, especially commercial branch, since usually all software came packaged with the operating system and was proprietary, meaning you could not use the software alone or the operating system and so on. Only the academic branch had a separation there. One other thing was they had Unix compatible software, but they of course didn't have the kernel. Especially they didn't have a kernel that could be run, that first of all would follow the GPL, meaning would be publicly available in open source, and that would be able to be run on normal everyday hardware, because there's also an issue of access. You can be very giving and pro-social by providing, sophisticated software if nobody can run it. So de facto, it looks good, but it actually doesn't help the world at all. So it's about keeping stuff or getting stuff that is actually runnable. And what they were missing there was the kernel. The kernel. Well, that's basically the core of the operating system that runs at all times and allows you to run other software around it, right? So you usually you're typing into the keyboard, you're interacting somewhat with the kernel, perhaps mediated via or a command line interface, but generally directly with the kernel. And they called this, kernel GNU herd, right? So of course it has a name suggesting that there's a GNU herd. Well, the point is, this kernel is still in the making. Now, and that was in 1980s, now we're at version 0.9. The last update I checked last night was in 2016. So it's, not incredibly fast moving as a project. In fact, there are recent moves to actually put Linux underneath it, so it's kind of defeating the purpose of it. But the point is, Linus Torvalds adopted the GPL in 1992, so 1 year after the actual release of Linux, and made it public on this basis. And since then, since it was Unix compatible, meaning again I mentioned before that Linux had a user interface that was compatible to Unix, sorry. It was basically the birth place for Linux to become the de facto standard kernel, the standard core operating system for GNU collection. So every time now you read something like GNU Linux, well, it actually means the kernel means Linux plus X plus software that is usually part of the GNU software collection. So a lot of the software you're actually using hasn't been developed specifically necessarily for Linux, but it was coexisting, but it's packaged with most Linux distribution. Yeah, so command line aspects that you know. But it's also important from a terminological perspective. If you're saying GNU Linux, you mean the operating system plus utilities, plus GNU software that comes with it. If you say Linux, you mean the kernel only, right? No software, like literally bare bone kernel. There's no concept like this. In fact, any distribution that you run has, of course, some utilities and tools that allow you to interact with the kernel to do something meaningful in the system, right? So it's important to get this right. And yes, so distribution is basically, well, I just put it there, GNU Linux plus X. That is a flavor of Linux, including those the core GNU software packages and other things that are specific to the distribution. Because in Linux, unlike Windows, we have a bit of a diversity in terms of flavors and specializations that distributions have. Some of you who use Linux have certain preferences, right? So some people who use Arch Linux. Does anyone use Arch Linux here? Good. Alpine Linux? Ubuntu? Cool. Fedora, very good. Mint? Good, yeah. Okay, so why do we have those different flavors? Jona, any idea?
I mean, just because people have different opinions of what is the best interface and what is the best collection of packages and systems to have on your computer, so they make different things.
Cool. So there was an important point. We usually talk about user interfaces, packages. So the choice that is available in terms of packages, but also user interfaces that different OSs have, Linuxes have. It's not like Windows where you have one user interface, like one GUI, but actually you can choose between at least 2 popular ones, but probably 5 available ones. So it's like you can really go off-road and trying, mixing GUIs with your kernel, which is something you will not be knowing from the Windows world at all, so. And that's precisely the point. And on top of this, there's certain preferences that different Linuxes have. For example, Fedora is known to be, state of the art de facto, right? They are kind of going down the risky pathway and having very recent versions of any software they're running, sometimes even somewhat experimental or still in testing phase, not really stable-ish. But they only I think they are updating the operating system every 6 months anyway, right? So then there's Arch Linux, for example, which has the idea, well, we don't really have versions, we have so-called rolling releases. You constantly update it, and therefore your Linux should be up to speed. Problem is, sometimes things don't actually kind of work properly together, so you carry along on a lot of incompatibilities potentially over time. You need to be, willing to actually go into the nitty-gritty to fix that.
Do you have any update of CentOS, which just released the operating system, which is container-oriented?
Okay. That's very interesting. No, I haven't. I need to come back. I'll amplify it for the class. There was the question whether, what about CentOS? It's also a very well-known older Linux distribution, or very traditional Linux distribution. They have direct container support, which is helpful in the context of cloud computing, and we'll talk more about containers in particular anyway. So it's a good, bring it back when you talk about this area. We should really highlight this. It's a very good point. So different purposes, some more in the server area, more security related. So Linux is, for example, for forensic purposes. Some of you guys may know from if you're in digital security. And some of them more for multimedia support because they have more codecs. And some of them also compromise the principles of open source software and actually allow proprietary software in there, especially if you want to do gaming. Like I think Steam OS is one of those, right? So you can actually run Steam on your under Linux, more or less, but it also, of course, requires you to have proprietary NVIDIA drivers to have the support for your graphics card and performance, and so on. So DistroWatch, a good page to go down to, but the important thing that I want to get across is, well, there are different Linuxes and they all have kind of slightly different flavors. Some of them have different command line interface structure, but fundamentally, it's under the hood, everything should be roughly the same. This is, yeah, exactly. So, okay, I think that's roughly the idea, just as a core idea. Any operating system usually has some sort of kernel. If you're hearing operating systems right now as a subject, you most likely talk about this as well, please.
You didn't mention Red Hat.
Red Hat, good one. We come back to distros in a second.
It actually become like commercial.
Yes.
It is licensed and you have to pay for
Yep.
it. It costs a lot.
Yeah, it does. We come back to that in probably in one slide. I'll come back to it. So there's a lot of good injections about different distributions, but we bring it back together because I want you guys to have an overview. Just to reinforce the whole idea about kernels, that's something you learn in operating systems, not here. But fundamentally, the idea is the kernel is the program that runs at all times, right? Something that's always running, and everything else will be started and stopped somehow. The system, the user space, so-called, that's where you operate, interacts with the kernel space, so-called, via a system call interface, where there are very core system calls that say something like write to hard drive, read from file, and things like this, where basically applications that sit in the user space can use those system calls to compose their functionality. Right? So you don't interact on this level directly, but the applications that you use actually do so. That's why you're programming for a given operating system, right? So that because you can only use a certain set of system calls or the compilers for that operating system. So if you use a C++ compiler for Linux, for example, it will compile against this system call interface. This is what's offered from the operating system, from the core. But what you will dealing with is user space. Usually that's user applications, some libraries that are provided, like the GNU C library, and that's GNU Linux then, just for the terminological viewpoint. Okay, so as there was an injection, how many Linuxes do we have nowadays, right? And sometimes it's good to step back, I guess. That's probably the way of putting it. All right, that's all I can go out. Okay, this is kind of a timeline of all the Linuxes that have been developed and see how they have branched out. This is, I guess, also a good indication of what happens if you take your project open source and if it's successful. Because people take it, change it, republish it. As I mentioned before, under GPL, perfectly legal. But this is the number of Linux distributions or the spread of Linux distributions that we actually have. More than going down into the nitty-gritty, we can see general trends. So if you see there's several branches I just want to highlight, and that gives you an appreciation of where the roots kind of lie. So to the far left, we see the root Linuxes. So in this case, now I'm zooming in again, so everyone has a chance to appreciate something of what's going on here. So again, let's see all the branches. And for example, a large number of Linux distributions actually root in Debian on the far left. I think I was made public or developed in 1993. Ian Murdoch, I think it was, and that became one of the core distributions in the Linux world. And many of other modern variants have been sparked of this. If you have dealt with Raspberry Pis, that's those slightly more beefy Arduinos, or they are not Arduinos, they are also mini kind of computer concept, but they're, for example, built on Debian. Similar Steam OS as well, you see it on the right here, or you may not be able to see it, but believe me, it's there. So they all derive from Debian. Then we have a few other ones. If you go further down, there's a different branch, Slackware Linux. You may read this as well at times. This is also a bit more raw, if you like. I think you need to have a bit more of a it was more on the hacker side in the sense that it had a less managed, initially at least, less managed software repository, aspect we need to talk about as well. But for example, if you have heard of SUSE Linux before, I don't know, SUSE, S-U-S-E, S-E, doesn't matter. This is derived from Slackware, for example, right? So that's one of the important ones. And then we come, of course, to the last important branch, Red Hat. So Red Hat, I think, is Canadian, right? It's a Canadian company, as far as I know, and they're specialized in consulting. So they actually weren't primarily focused on, just only an operating system. But the idea is they wanted to penetrate a market for open source software using Linux as an underlying operating system, and started to make their own distribution, Red Hat Enterprise Linux, I think it's called, and to sell sell licenses for this, so introduce a licensing scheme, but more importantly, provide professional support. So it's quite important because Linux per se is not really, officially supported. So if you run your Linux and you have a problem, your best bet is Stack Overflow, right, or something like that. There's no per se, a company you would call up and ask for help. Well, in Ubuntu we have Canonical, but even there, don't try calling them. They will not pick up the phone. They will point you to the newsgroups, fora, perhaps chats if you're lucky, and so on. So it's not really their obligation at all. But Red Hat made it theirs. So actually supporting, have developed one Linux distribution, a lot of folks from there, and became most popular with Red Hat Enterprise. I think at one time it was the most important Linux that was out there. Once it wasn't as broadly adopted as it's nowadays, but there's quite a bit of spread and branching out of this. And one out of this branch is Fedora, the one just mentioned by Jone. So that's basically the experimental version of Red Hat Enterprise Linux. They put everything in that's new and fresh, maintain it for 6 months, see what breaks and what doesn't, and then put it into the Enterprise Linux. But it's for that reason that Fedora is free, completely open source available, and whereas Red Hat Enterprise is not. So they were quite pioneers in a sense. In fact, when they started up, they gave Linus Torvalds a stake in their company for free. So just to be committed and show their commitment to the whole Linux idea. So they're more like the commercial branch, not like the bad commercial branch, but I think good commercial branch. Promote the use, otherwise companies wouldn't have touched it. Remember, we're still talking 90s, early 2000s. That was a time where people said, software is not something we do. Now people realize, oh, everyone does software, right? So there's more responsibility and more IT necessarily guaranteed. Debian, Slackware, in case you want to trace it and look for your favorite Linux distribution, for example, Android is also in there, but it has a very, very small branch because it's quite recent. So there's different ones, right? So I listed a few examples here. Commercial ones, they are Red Hat, Fedora focused. Ubuntu, probably the most popular one, or at least was the most popular one anyway, because it was a very solid ecosystem. It ran well, it had a good recent supply in software, and it was end-user friendly. So whereas Debian, for example, this one here, is really more like was a server operating system. It was meant to be run on servers and provide software, but not really to be dealt with by the user, right? So Ubuntu took that leap and actually do it. And since then, there were further forks from Ubuntu. For example, Mint. If you're running Mint, you're running Ubuntu plus different user interface and a bit different software, or Elementary OS. I'm not sure if that's still maintained. Alpine OS, we meet this guy again later on because it's very small in footprint, so it's often used for cloud applications nowadays, and of course SteamOS and so on. So every time you read LTS, Marius would mention this means long-term support. Those are the versions that are supported for longer periods. If you have an Ubuntu and you're choosing between Ubuntu and Ubuntu LTS, well, if you want to have long support, you take the LTS version. If you want to be bleeding edge, take the other one. Long-term support means it's more stable as well. Means also that packages may be more outdated. Yeah, so there's always this trade-off of, do you want to be bleeding edge or do you want to have stability over time? In cloud, we often say stability, but for the sake of learning here right now, initially we say bleeding edge, right? So it's kind of a bit of a shift. There's a bit of a conflict in terms of university.
One
setup.
note on that.
Yep.
Once you get too old, stuff start to be unstable as well.
Yeah.
Especially when on release stuff, because everything you see and search for online will become invalid when you get too old. So if you're on a Ubuntu 14, you probably won't find all that much help for the problems you're having when you're trying to deal with modern software on a really old operating system.
Please.
I don't hear anything.
Yes, I repeat it. You heard me though, right?
What?
You heard me before, right?
Yeah.
Somewhat, right? Okay. There's an option. The option is here. Anyway, no. What Jonas said is you need to be careful which version of an operating system or Ubuntu or whatever else you run. Because if you're running an older version, most likely you will not find up-to-date, feedback, support, and the like. So it's quite important to know which Linux and which version of it you're actually running currently to expect meaningful, entries. So if you are running Ubuntu 12 and you're seeking support in Stack Overflow, it's hard, right? Because you really need to look that you get the right version. Conversely, though, for the most recent one, it's equally hard, right? Because usually it's more like a stably entrenched, like 1804, which is the current LTS by Ubuntu. So that was April 2018. So that's the versioning scheme. So 18 and then the month. That's probably the most penetrated one, but it will change as a fluent process over time. So be mindful which Linux you seek support to. It's not like Windows 10, which is roughly Windows 10. Of course, they also have releases, but the changes are usually not breaking. It's quite a bit different perspective there. Good. Okay, so different Linuxes have different formats. So this is probably the most common differentiation of the big packages, big systems. That is, they actually deliver software not in set Excel files like in a Microsoft Word, but rather in terms of packages. Right? Each software is packaged in one of those formats, RPM being the classical one, the Red Hat Enterprise Linux format, and does Fedora still use it? Yes, right? RPM packages? Thank you. Debian has the apt, the advanced package manager, packaging tool, Slackware, Slack packages, and for Arch Linux is Pacman, and so on. Right. So this is important to know because once you understand one of those packaging systems, you kind of have you kind of fall in one bracket. For example, I've been for ages only working with APT systems, base system Debian onwards, so I feel very comfortable in this world, but I would feel less comfortable with the SUSE, which, for example, or with the Red Hat distribution that relies on RPM systems. So I think for me that's the most important differentiator between the Linuxes, that is which packaging system do they actually use. Which sounds weird, why would you bother about packages? Well, that's the most common way of installing software on Linux. It's not like you're downloading setup, double click and hopefully it works. You're actually running specific commands to install new software. You haven't done that last week. You actually forced you to do some really manual, tedious process. There's a reason for that, which I'll come back to tomorrow most likely. Okay, market share. Well, I'll jump over that. I just rather want to go into some command line a bit, else we're running out of time. So if you want to interact with your Linux, most likely you need to interact using a terminal, right? So at least we do that. And it's there are various versions of that one. Again, it's kind of a tree like this. They have an original, the Thompson shell, that was delivered with the original Unix, and there's various variants where people felt, well, my user interface should be slightly different, and yours, again, it's part of the open source movement that comes along with this. And I think the convergence is largely on Bash nowadays. So the Born Again shell, which is kind of a slightly updated version of the original shell, mostly the default shell. You can change it though. And you can also change it per user. That's nice. In Windows, you're kind of tied to your shell, right? Command line interface. If you say shell, sorry, means command line interface. But in Linux, you're not. Every user could have a different one. You can also start a shell within a shell, if that makes sense. I don't think it makes, but whatever. So people sometimes change their shells for different purposes. Yeah. So how does the system in principle work? Right. Since it's Linux or derives from Unix, it actually fundamentally networked. So we have this core, this kernel, and we have shells connecting to the kernel to interact with this. And they're usually connected from a remote terminal, right? So traditionally. Now it all happens in your own screen. But even you have 6 terminals by default, usually, especially I think in Ubuntu anyway, 6 terminals that you can use on one machine and switch in between. We'll talk about how that works tomorrow. But the fundamental idea is that that's your means of interaction here. And the terminal looks something like this. If you have started up your Linux, you get something like this. Yay, nay? Or do you get a user interface? In which case, you need to look for the terminal tool that is installed in the system, or Xterm, or whatever else is available. Usually by clicking on the top left, there's this Ubuntu button, and if you're in that world, you type terminal, and there should be some sort of console coming up. Terminal, console, same thing in this context. Once you do that, you see something like this. And that's your command prompt, right? So similar to Windows a bit, but not really. But the idea is that you have, it indicates the user, you are the host you're logged in on, what rights you have fundamentally, and what directory you're in. So, for example, here we see tilde. Tilde implies home directory. So each user on a Unix system has a home directory. If you see tilde, it means you are in the home directory. And the $sign here means you're operating as a regular user, not a super user. That's also one important differentiation between Windows and Linux. We have a concept of users and super users. What's the difference? You?
Well, you could probably do more if
You are?
you have more permissions.
Yeah. So basically, kind of. So the super user privilege is all permissions. Well, he doesn't have all permissions, but he has the permission to give himself all permissions. Fundamentally, even the super user can be constrained, but he's the only one who can unconstrain to some extent. So you can get it wrong. But the point is, there's two levels of users, and unlike in Windows, where we usually work as admin on the machine, or many people do, in fact, they shouldn't, but in an enterprise environment, often not, but privately, most likely. In Linux, you never do that, right? You always work as constrained users and give yourself super user privileges if you need them. And the tool we use for that purpose is called sudo. You have seen that before. Where you probably saw that on the command line when you used followed some of the instructions that we gave, because there's a lot of sudo in there as well. If you, however, instead of this $sign see a hash symbol, that indicates that you're actually currently working as super user. So mindful, you can do a lot of things wrong, and many people have probably realized already, Linux is not the most verbose operating system in terms of feedback. So if you give it a command, it just does. It doesn't necessarily give you any, what nicely, well done, everything went well, or if something went wrong. So it's not really super verbose. It's meant for people who kind of know what they're kind of doing. So you can do horrible things quite quickly, unlike Windows, where you get 5 prompts and you need to repress those 5 prompts and probably some add screen in between before something actually happens. In Linux, not, right? You're running something and that's roughly it. So please be mindful. By default, please run as regular users, not as super user. Okay. Okay, now we know how the terminal, the prompt looks like. And before I leave you in a second, how do commands look like? Well, in Linux, we have commands that are usually following that syntactic structure. We have a command, ls, for example. Here's an example. Then we have options for that command, and then we have the arguments for the command. What's the difference? Well, the idea is that, arguments are kind of the input, what are you operating on, and the options modify the behavior of the command. So using the command ls as an example, what does ls do? Anyone? Yeah?
Show all the files and subdirectories.
Cool, yeah. So it basically just show all the files by default in the current directory, right? So just files and folders in the current directory. So, and then you have various options, such as -l in this case. L means long, so show the long format. So don't just show me, probably can still spin up a example. Don't show me the just a list of different files and so on in there, but actually show me including directory paths and so on. Give me a bit of a richer feedback. And then, of course, you decide which folder you're doing this on, for example, /etc. We'll talk about this. Unfortunately, tomorrow. We'll not have the time to do it today. So show me the content of etc in long format. That's the rough idea. And then there's two kinds of options, usually in the form of --, meaning longer, more explicit options, and shorter ones with some simple else. Usually there's two versions for each option. One is more legible, the other one is not. So one is more used for scripting purposes, the other one is more for interactive purposes, meaning where it's really about conciseness and being quick typing something. So here's an example for the command user mod. there's I'm circling. There's the command up there. So I typed, or this screenshot basically shows user mod dash dash help. Show me the help for user mod. Dash dash help is kind of a default convention for you to actually show a short help of the corresponding command. So if you have a command that someone gives you, such as grep, cat, tail, pet, you can just type spash dash dash help, and you should get an overview like this, basically telling you, okay, what are the options that I actually have here right now that I can use. And you see for many options, you see two versions. One of them with a single dash, like dash C, and a double dash, dash dash comment, for example. One of them being the more verbose one, the other one the more simple one. It's oftentimes like this. Looks redundant, but one of them is more legible, the other one not. Okay, right. So the thing is there syntactically, that's why I'm showing you this stuff here. The stuff on the left side, of course, the command is compulsory and the arguments are compulsory. The options are generally, well, let's call them options, optional, right? So we don't necessarily require those ones. But it's just to get those, for you to be able to read those help statements more explicitly. Okay, right. And the other thing is that options may actually have parameters themselves, right? So we see, for example, the option dash A, which does not specify any parameter, but there's the option dash S, for example, which requires you to specify which shell will be associated with this command. In this particular case, it's about changing user settings. Here it's about changing the user's default shell. In this case, you of course need to specify the shell, right? So hence the different syntax here. If it's capitalized, it's a mandatory parameter for the option as well. Okay. Good. Before I leave you, a few things. So we know now that we have commands. We know now that commands have most likely help, and you hopefully be able to read the help. So I ask you to explore that later as part of your homework for tomorrow, whatever that means. But there's also one other important command that's very, very important to know about. It's man. And no, it doesn't stand for that. It actually stands for manual. And the idea is that any command that you're using or any tool that's available on Linux is managed in some sort of central help system that has the full specification of its usage. And this is the man tool, right? So if you say man ls, it should spit out the manual content. That will be tiny. We'll see. It should spit out the manual content for ls, right? So you suddenly get into this one. And this is actually a fully interactive tool in itself. So it's no longer command line, spitting out the core options or whatever, but actually a comprehensive documentation of the tool, including all the options, including all the description, synopsis, different exit status they need to be dealing with. So it's really more geared a bit more at the Zorro developer, if you like. Whereas if you run man -- help, it's very straightforward, and you immediately return back to the command line, so you can continue. It just prints briefly all the options as well. So there's always two ways of doing it. But if you want to learn something about the tool, it's generally man. The man tool itself. If you're just briefly getting the characteristics right and being able to type some commands properly, then the help will do for you. But so now we're in the man tool here. If you're in there and you feel caught, just press Q to quit to get back out of it. So it's like an interactive tool. So the manual also has a manual about itself. That's sometimes quite helpful if you want to learn more about this thing. If you type man, it actually shows you a manual of the manual. And how is the manual set up? Well, it's not just that we have a tool and that the tool has a manual page, but more importantly, manuals are structured in sections. So there's section 1, 2, 3, 4, 5 until 9. And they describe a tool in the context of its function. We can have executable programs that we know. We can have system calls, the kind of stuff that sits between operating system and the user space, so-called. We can have file formats. We have games, whatever. And we have system administration commands. And the reason why it's differentiated in this way, you could say, well, if I give my command, just show me the page, the help page, right? Some of the tools may actually be in multiple sections from a different perspective. Right? So some tools, for example, like,
Isn't your meeting starting?
Yes, my meeting's starting to leave. thank you. There's Git as a developer tool, and there's Git as a user tool available, right? So depending on what you're interested in, the library calls, for example, emanating from Git, you could select a different section as opposed to the command line tool that you're going to use. So that's the idea there. So if you go here, and do we have Git on this one? We do. If we say man.f Git, it should show me all the occurrences of Git, and it says, oh yeah, cool. So we have Git in the section 3. I think it's related to the libraries. That's the Perl interface for Git. Good. And then we have Git, the command line, the stupid content tracker, so you may know it, in section 1 as an application tool. So that's the key idea there. All right. I put on the slides later, so there's a lot of different commands that you want to know and learn about within try out. For example, we have pwd showing you the current location, ls listing files, cd moving between directories. We'll go into it tomorrow, don't worry about this now, because it's a bit involved, that's one. And I put the slides on later. For homework, I'll ask you to explore those following commands. And now, knowing the command line briefly, that is, knowing man and help, you should be able to figure out how to use those commands and tell me tomorrow what they do, right? So that's the homework. That's as far as we push it here. Yoni will take
I might
over.
cover some of them.
Yeah, cool.
Like now, after
Good.
this.
You want to go for it? Yeah. Good.
Not all of them.
Thank you very much. We see each other again tomorrow, 8:30 here. So we make up for whatever lost time, and Yoni does something. Yeah, you can give more tips and whatever you want. Cool. Well, thank you very much.